Here we go. Our last lesson for this unit, we're going to be looking at linear inequalities that are graphed as systems. So, which of the following is the equation for the linear inequality expressed above? It's just a little bit of a review. Do you remember what determines if a line is solid or if a line is dashed? Do you remember which determines if a line is solid or a line is dashed? Good, yeah, so the equal sign here is going to be solid, so we can get rid of that one. We know that one's gone right away. All right, is the slope positive or negative? Slope's negative, so we can get rid of letter B too, can't we? Now the question is, this says y is less than, this says y is greater than. Y is less than and y is greater than. So if I go to my line, y is up and down, right? So if it says y is, or as I move up, that means y is greater than. So it's going to be letter D right there, letter D. So we are going to verify whether or not points are a solution to a system of inequalities. So we're not going to do this example right here, but maybe you remember graphing a couple lines and then shading the overlapping region. So can somebody give me a point that lies in that region right here? Just any point. 1, -1, sure, that would be perfect. So 1, -1 would sit right about there. That means if we plugged it into both equations, it would work. So let's see if these are solutions to these two equations. I will do both of them. Y less than or equal to -3x plus 1 and y less than 2x plus 2. So what value do I plug in for y? So is -3 less than or equal to? And then I have -3 times x. What's -3 times x? So -3 times -1 will give me 3. And then plus 1. Is -3 less than or equal to 4? Is that true? Yeah, so it satisfies the first inequality. We're going to check to see if it satisfies the second one. Again, for y, I plug in -3. -3 less than, and then 2 times -1 is -2 plus 2. So is -3 less than 0? Yes. So because it works for both, it is a solution to that system. If it works for both, it's a solution to that system. Look at the next one. We plug in -1 for x, and we plug in 5 for y. Is 5 less than 2 times -1 is -2 minus 1. Is 5 less than -3? No. So it is not a solution to the system. It must work for both. Try number 3 on your own. Go. So I ended up with 1 less than 2. And I ended up with 1 greater than or equal to -1. And both those worked. So I say yes. Any questions on those two? Okay. Last page of notes. Let's practice graphing the inequalities. I have y is greater than or equal to -x plus 1. I will first plot 1. As I plot 1, I have a slope of what? So over 1 and down 1. Is it a solid line or a dashed line? It says y is greater than. So if y is greater than, would I shade up here or would I shade down here? Up. Y greater than, so I just move up, and since I'm up here, thank you. Thank you. We take a class in college on shading, so we can be prepared. Very much not true. Love the glasses. Y less than 3. Uh-oh, that's a little bit different than what we've seen, isn't it? I don't know if you remember this, but x equals 4, that's what we call a vertical line, and y equals -2, that's a horizontal line. So this is going to be a horizontal line. What value do you think it goes through? 3. Solid line or dashed line? Y less than 3. Do you think I shade above or do you think I shade below? Below, because it says y is less than. Yes. Horizontal, vertical? Excellent question. Most people are thinking the same thing. You're the only one brave enough to ask. So let's check it out. That is the coordinate 2, -3, correct? Yeah. This is the coordinate 1, 2, correct? If I draw a line, notice how the line is vertical, isn't it? I'm sorry, this is not 1, 2, it's 2, 1. Sorry about that. So if I draw a line through those 2 points, it is a vertical line. As you look at an equation for that line, anytime, so positive slope, negative slope, zero slope, undefined slope. So when you get these two, you got to be careful when you're doing your equation, okay? So it's an undefined slope. It has an interesting equation. What do you notice stays the same? It's that value 2, right? In fact, if you found any coordinate, like this coordinate here, that would be the coordinate 2, -1. The x value always stays the same. So vertical lines have x equals equation. Horizontal lines will have y equals equations. Now, I asked first hour, and they definitely had opinions about it. I'll ask you as well. Would you like to graph this by putting it into slope-intercept form, or would you like to graph it by finding the x and y intercepts? Okay, so we'll do this one using intercepts. And we'll do this one by putting it in y equals mx plus b form. So I just want to be clear that you can do either, okay? So let's try this out, okay? If I cover up the x, I have 3y is 12. So what's the y-intercept? 4. Everybody okay with that? If I cover these up, I get 3y is equal to 12. So therefore, I'm going to plot 4. All right, if I cover up the y's, I have 4x is equal to 12. So what's the x value going to be? 3. So I plot 3. Solid line or dashed line? Uh-oh. Now it doesn't say y is greater than or y is less than. So we got to think of a way how to shade this. So I'm just going to test a point. What point is this right there? So if you plug in 0, 0, would you agree you get 0 is less than 12? Is 0 less than 12? So therefore, we shade towards 0, 0. For those of you who liked that option, good for you. Continue to roll with it. For those of you who are like, there's no way I would have chosen that option, I don't like that at all, then do this instead. Just put it in slope-intercept form. Subtract the x from both sides. We get -3y is less than or equal to negative x minus 9. Now what? Divide by negative 3. What do I have to do when I divide by negative 3? Flip the sign. Yeah, y is now greater than or equal to 1/3 x plus 3. I know how to graph that. I plot positive 3. Then I use my slope of 1/3. Up 1 and over 3. Solid line or dashed line? Do I shade above or below? It says y is greater than. Since it's such a wonderful day. There you go, Barron's just for you, man. What's that? Yeah. What's different about this one? There's 2. So we're going to shade the overlapping region. I start with this right here. I'm going to plot positive 3. And I use my slope, down 2 and over 1. Solid or dashed? Do I shade above or below? I shade here. Y is greater than. I shade above that line. I'm just going to make some arrows because that way I can decide which of the 4 areas I want to end up shading in the end. So y is less than or equal to 1/2 x minus 2. So I plot negative 2 for the y-intercept. And then up 1 and over 2. Up 1 and over 2. Solid or dashed? Good. And it says y is less than, so I shade down. So can you see these 4 different regions? Can you see the one that we're going to want to shade? Yeah, the bottom right, that's where both the arrows are going. We're going to shade this vicinity right here. So all the points in that shaded region will work for both of them. Last one. I'm going to put it in slope-intercept form. I'll subtract the 3y from both sides. Whoops, sorry. I'll add the 2x to both sides. I have 3y is greater than 2x plus 15. Divide both sides by 3. Y is greater than 2/3 x plus 5. So I plot positive 5. Instead of going up 2 and over 3, I'm going to go down 2 and back 3. Just try to pick up my point there. It says y is greater than, so I would shade above. Watch what happens if I put the next one into slope-intercept form. I get y is greater than 2/3 x minus 2. What do you notice about the lines? They're parallel. What does that mean? They're not going to cross on this two-dimensional surface. And so you might be tempted to think there's no solution to this system. But that's technically not right. When it has inequalities, you see y is greater than, so that means I'm going to shade above. So how many regions is this graph kind of divided up into? I'm going to say 3. The bottom, the middle, and the top. Everybody see that? So are they both shading the bottom? Are they both shading the middle? Are they both shading the top? Yeah, this one will eventually reach up to the top, and this one. So the solution for this is that top portion. How's that, Josh? Little purple highlighter? Why are you hating on my smartboard? Okay, then what do you want? You want like that? True that. Pretty sweet.